we're going to be going over 2015 FRQ number 6. So they give you a Maclaurin series for the function f, and part A asks to use the ratio test to find r, which is the radius of convergence for the Maclaurin series. To find the radius of convergence, you're going to use the ratio test, and your a sub n expression is going to be negative 3 raised to the n minus 1 times x to the n over n, and your a sub n plus 1 expression is going to be negative 3 raised to the n times x to the n plus 1 over n plus 1. And then you're going to make your expression, which is a sub n plus 1 over a sub n, and then you're going to cancel out the negative 3's and the x to the n's, and you're going to be left with negative 3 times n over n plus 1 times x. And then you're going to find the limit as n approaches infinity of the absolute value of this expression. And as a helpful reminder, when you find the limit as n goes to infinity of n over n plus 1, you can divide top and bottom by n, and then find the limit as n goes to infinity, which just gives you 1. And so the limit as n goes to infinity of this expression is 3 times the absolute value of x. And to actually find the radius of convergence, you want to set your expression less than 1 and then solve for x. And so the radius of convergence is 1/3. In order to earn full points for this part, you're going to need to set up the ratio, which will give you 1 point. You will also need to find the limit as n goes to infinity for the ratio, which will earn you another point. And the last point can be earned by determining the radius of convergence. So part B asks you to write the first 4 non-zero terms of the Maclaurin series for f prime, which is the derivative of f, and they want you to express f prime as a rational function for when the absolute value is less than the radius of convergence. So to do this, you first need to determine the first 4 non-zero terms for the Maclaurin series for f, which are x minus 3 over 2x squared plus 3 times x cubed minus 27x to the 4th over 4. And then you can find the derivative of these terms individually, and so then you have f prime will be equal to 1 minus 3x plus 9x squared minus 27x cubed.
A common mistake is that students will try to find the derivative of the given series instead of the individual terms.
And if you look at this, you can see that each of these terms is being multiplied by negative 3 to the x. And so to express the Maclaurin series for f prime, you can use the equation where you have the first term over 1 minus the ratio, which is negative 3x. And so you would have 1 over 1 minus negative 3x, which would just be 1 over 1 plus 3x.
It is important to remember that this can only be used for geometric series.
3 total points can be earned for part B, and you can get the first 2 points by listing the first 4 non-zero terms, and you can earn the third point by using the formula and figuring out the rational function. Part C of this problem asks you to write the first 4 non-zero terms of the Maclaurin series for e to the x, and then use that Maclaurin series to write the third degree Taylor polynomial for g to the x, which is equal to the product of e to the x times f of x about x equals 0. So for this problem, a helpful reminder is that e to the x can also be written as the sum of x raised to the n over n factorial from 0 to infinity. And when you expand this, you get 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. And to find the third degree Taylor polynomial for the product of e to the x times f of x, you can multiply the 2 expanded forms. And so this is the expanded form for e to the x, and this is the expanded form for f of the x, which was given to us. And then when you FOIL this out, you're going to get x minus 1/2 x squared plus 2x cubed, and the problem only asks you to find the third degree Taylor polynomial, so you can stop there, and your answer is just going to be x minus 1 over 2x squared plus 2x cubed. So for this problem, a total of 3 points can be earned, and the first point can be earned by writing down the first 4 non-zero terms of the Maclaurin series of e to the x, and this is something that would be helpful to memorize, and also look at the Maclaurin series for ln of x and sine and cosine. And then 2 points can be earned for writing the Taylor polynomial, in which you multiply e to the x times f of x, and if you get the correct Taylor polynomial, you will get your 2 points.
Here I have given some helpful formulas to memorize to help you with problems like this. This is a link to a PowerPoint that has multiple FRQs that relate to series, and it has solutions, and I would highly recommend looking at these if you are having trouble with the series FRQs. I would also recommend looking at problems from Chapter 11. The 11.7 homework problems are exceptionally helpful.